Okay, I think everyone is here. Hazi, 20 to 21. Okay, so we are recording right now. Assalamualaikum, good morning again. Kepada yang baru join. Macam saya cakap tadi, kita akan, our agenda for today is saya nak mulakan our class with a briefing about your infographic poster assignment. And then juga after that kita akan continue with our lesson lah, the last topic of chapter 3. About your, I shared my screen, yes. Okay, so about your infographic poster assignment, I've posted a link, an instruction dalam your ITEL. So if you go over to ITEL in my module pharmaceutical chemistry, kamu scroll to the bottom part of general, ada infographic poster assignment as you can see on my screen right now. So if you click on this, saya dah bagilah all the tajuk. Ada 8 tajuk ke semuanya. I forgot. Ada 8 tajuk ke semuanya. So kalau kamu ada, tersilap saya kamu ada 6 group ke semuanya. You can choose satu, okay sorry. Saya akan assign 1 sampai 8. Saya akan assign topik kepada each of your group. Okay, so you cannot choose lah. But saya nak tunjuk kat sini adalah macam mana kamu nak buat this poster based from the tajuk. If you read the tajuk each topic 1 sampai 8 ni, ada most of them ada satu link saya attach dekat sebelah. Okay, ada 3 yang tak ada. History of atom tak ada link. Solar panels tak ada link. Water treatment tak ada link. But yang ada link ni, if you get this topic, saya nak kamu copy this one to get an article. But before you can access that article, you have to sign in to this website. So this website is Royal Society of Chemistry. Ke atas, the top right, ini saya dah masuk, saya dah sign in my account lah. Okay, so if you want to read this article, you have to sign in first. It's just a simple registration of your email and your username and password, that's it. And then dia akan bagi kamu a verification link dekat your email. Click on the link and then kamu boleh kamu dah register lah, you can access this article. So once you have registered, you can read the article. So kalau kamu nak buat the infographic, kamu boleh dapatkan your isi-isi penting dekat sini lah. You can read about greenhouse gases dekat sini. A super greenhouse gases. So dekat sini the article is C43 SF5. So this is the chemical yang dia panggil, yang dia bukan depan. What's the word? Dia dikenali sebagai super greenhouse gas. So I want you to read up. I want you to explain in your infographic why is it known as super greenhouse gas. So there's a plethora of information dalam artikel ni. Kamu boleh pick and choose to the ones that is related to your to our module pharmaceutical chemistry. Meaning saya nak kamu pilih isi-isi that yang di cover dalam our chapter 1, chapter 2, 3 sampailah 8 if you can read ahead. Okay, tapi kalau tak boleh, buat setakat yang kamu belajar sekarang lah, 1, 2 dan 3 dulu. Okay, so ada banyak information kat sini. You have to read, discuss among your members, your team members, and then pilih which ones yang kamu nak masukkan dalam your infographic. Okay, so ada 1 sampai 8 kat sini. Yang tak ada ni, kalau yang tak ada link ni, kamu boleh search on your own lah. Okay, mainly saya tak bagi because dah ada already infographic regarding this topic. So, tapi tak senang nak cari that infographic yang saya tunjuk pada kamu last week tu. So if you're lucky, kalau kamu jumpa, saya tak nak kamu copy and paste saja. Saya nak kamu add information yang tak ada dalam the infographic yang kamu jumpa tu. Add new information related to the module. Alright, okay. Second topic, saya nak kamu boleh buat the infographic using any app yang kamu nak, but saya nak recommend kamu guna Canva. So Canva, kalau kamu tak pernah dengar, kalau kamu, excuse me, what are you doing? Okay. You can see yourself. So, okay, so Canva, no touching. So kalau kamu tak pernah guna Canva, tak pernah dengar pasal Canva, this is Canva. You can just register, make your own account for free dekat www.canva.com, or you can download the app on your phone. So kamu boleh edit this infographic using any device that you want lah, laptop ke phone. Tapi it's easier to do it on your laptop because you have bigger screen. You can you can use your mouse pad, so it's easier for you to do editing menggunakan your laptop. But saya pernah edit guna phone, it's not impossible. Okay, it's doable. So kalau kamu tak ada laptop, it can be done menggunakan phone. Macam mana nak guna? It's kalau nak guna infographic, you just type in infographic. So dia ada template kat sini. Yeah, so infographic, dia punya size pun is standard. So saya nak kamu gunakan this template 800 darab 2000 pixel. So once you have chosen that template, so ada banyak template lah you can choose from. Okay, you can use whichever that is the most convenient, the one that's fit your style the most. You can choose after you discuss with your team members. So it's easier, that's why saya prefer kamu guna Canva. Kalau kamu dah choose a template, for example, katakanlah kamu choose the first one here. So the interface, it's simple. Ada banyak pilihan dekat sini. If you want to change your template, dekat belah kiri ni ada pilihan. Okay, dekat apa ni? And then bawah sini ada elements, which means you can add inilah shapes and designs. You can edit the designs based on the elements that you have. Ada shape, graphics kalau kamu nak guna, ada stickers, photos to make your info poster more interesting. If you want to upload your own picture also can. Okay, kalau kamu nak upload your own design background, you can upload dekat sini. You can choose your text, your design for your text, your typography also through here. Ada banyak pilihan. You can animate them also. You can add photos, ada logos. So that's why saya saya recommend kamu guna Canva because it's convenient. Semua dah ada, it's simple, the interface is user friendly. So kamu tak perlu fikir banyak macam mana nak buat the poster. You have to just focus on your content. Free ke ni free pun dia ada dua, free and premium. Kalau kamu ambil free, for example, ada certain design, ada certain logos kamu tak boleh access lah. Dia akan macam kat sini saya account education. This is for teaching, teachers punya account. So I have access to all the, saya tak ada restriction lah. I can use any of the elements, the shape. So semuanya free. Tapi kalau kamu guna account free, you get the basic inilah shapes and lines and graphic. Ada juga. Okay, it's not ada banyak pilihan. That's what I mean to say. So tak semestinya it's too simple. Okay, so dengan free also kamu free account also kamu boleh buat a nicely designed poster. Okay, any questions tentang so far tentang your assignment? Okay, kalau tak ada, thirdly, you need to register your groups, your team members. If you head over to the chat room, saya ada mana the chat? Saya ada post the link, a Google form. Let me post it again. Mana dia? Where did I post? I'm not sure if you can see this. Okay, forms Google. Okay, saya baru post, I reposted. So that's the link. You can register your team members. So please click on the link dekat dalam chat room. Click on the just one wakil lah. So each group pilih satu wakil, and then click on the link and isi your team members, nama team member dalam group tu. Lepas ni saya akan edit the link, saya akan attach the tajuk to each of your groups. So later on saya akan bagi the link again with the tajuk next to your group. So kamu boleh tengoklah rujuk dekat situ, kamu dapat tajuk yang mana satu. Saya akan pilih randomly, saya akan buat cabutan virtual lah basically. Saya akan buat sendiri. Nanti by tomorrow saya akan bagi the link. Okay, the earliest is after class today, the latest is tomorrow. I'll show you the topic by sharing you the link. Okay, so far any questions? Kita go through 3 things. For regarding Canva, kalau kamu tak mau guna Canva pun no problem. If you prefer to use PowerPoint, Photoshop or any other app yang kamu sudah selesa guna, kamu boleh guna whatever app you want. Due date is the end of semester. Saya kena tunjuk master plan lah. The last day of this before study week bermula. Okay, later nanti saya with the link of the topic nanti saya akan attach the due date. The last day submission is the last day of the semester before exam week start. So you have about like 4 or 5 weeks lagi lah. Okay, no more questions tentang your assignment. Okay, so kalau tak ada, saya nak mulakan our lesson today. And also one more thing, saya cakap this week nak buat test kan, tapi saya change lah to next week. Okay, because chapter 3 pun belum habis lagi. So once today kita akan habis chapter 3, and then you have 1 week to study. You have before next week's class, you have 1 week to study chapter 1, chapter 2, and chapter 3. And then on Monday lah, next Monday on your class, saya akan bagi the link dekat ITEL. So kita akan buat the test menggunakan ITEL macam kamu buat your tutorial hari tu. It will be 30 questions, MCQ ataupun fill in the blanks. Dia akan cover macam 10 questions from chapter 1, 10 questions from chapter 2, and 10 questions from chapter 3. So saya akan cover all of the chapters evenly. Okay, so let's start our lesson today. But before kita mula today's lesson, banyak before, saya bagi homework pada kamu to watch this video. So what I want to do today is saya nak explain what they say in the videos. So ada 2 video yang saya recommend. The first one is video 41 and video 42. Orbitals, crash course chemistry and orbitals, the basics atomic orbital tutorial. So we watch the first video first, and then saya akan stop. So ada saya play the video, and then sampai at certain point saya akan stop and saya akan explain. So that will be the format of this. Inilah my elaboration today.
We spend a lot of time.
Wait a minute, saya nak buka subtitle.
We spend a lot of time thinking about atoms as looking like this. There's a ball, and there's a stick, and there's another ball, and another stick. It's just a bunch of balls stuck together by these little wooden bonds. Simple, pretty easy to understand, and thus, as you have probably come to expect, it is entirely incorrect. Nuclei really can be understood as little balls, and that's more or less correct. Though when you get to some of the bigger, less stable ones, they start looking more oblong and weird, like a rugby ball. Atoms are basically ball-like as well, with electrons in a spherical cloud around the nucleus. But molecules, as we discussed last time, do not look like balls on sticks. Bonds don't form into neat little lines. They form from overlapping electron clouds, or shells, flowing around the nuclei of bonded atoms. If you really get down there and understand what they look like, they're like lumpy, clumpy globs of probable electron locations. And these lumpy clumps of probable electron locations do not behave the way you might initially expect them to behave. Oh no, that would be far too simple. They behave based on quantum mechanical three-dimensional wave functions, probabilistic distributions of electrons in space. And yeah, by the end of this episode, you're gonna understand what I just said, and it's gonna be awesome. Let's start with water, because all the interesting things on our planet start with water. It's also universally common, not just on our planet, but in our galaxy and our universe. Case in point, in 2011, astronomers discovered a cloud of water ice surrounding a black hole that contains 140 trillion times more water than we have here on Earth. And while we don't have any confirmed worlds covered in water outside of our solar system, we do have some right here in our solar system. Europa contains so much water, probably salt water, that its entire surface is just ice. What did any of that have to do with atomic orbitals? Nothing. I just felt like maybe I scared you with all that quantum mechanics talk before the intro, and I wanted to chill you out for a second. Okay, so water. We did its Lewis structure last week, remember? Each hydrogen bonding to the oxygen atom, and voila. But that drawing is linear, just a straight line through all the nuclei, and we know just instinctually at this point that water is a bent molecule. But why? Why is water crooked? Unbonded atoms within a molecule generally like to be as far away from each other as possible, especially if they have the same partial charge as the two hydrogens do with their partial positives. But something is keeping those hydrogens closer together than they would like to be. So why on earth are they not stretched out as far away from each other as possible? I ask this because if they were, the water molecule wouldn't be polar, and if water was suddenly nonpolar, we would all instantly die, as would all life on Earth. And suddenly we realize that this seemingly normal thing that we all knew about the world is really weird. And weird stuff is my favorite stuff because it means interesting questions. Interesting questions I want to know the answer to. It's an even more compelling question than what the heck is a quantum mechanical three-dimensional wave function? Well, of course, the answer to this question has a great deal to do with quantum mechanical three-dimensional wave functions, so let's start there. Oh look, I've got a telephone cord. This is
Okay, so far apa yang dia dah cover adalah what we have covered last week. So last week dia ada explain tadi. Oh, ayah, always does this. Wait a minute. Kenapa dah jadi macam ni? Right. Okay. So apa yang dia dah cover dalam that video tadi, dia dah kata electrons basically are not static. It moves in a cloud of electrons. And they also mentioned molecules isn't what we depict it to be. So tadi dalam that video dia tunjuk a molecule that is bonded sticks and balls. Okay, just a ball bonded to another stick and a ball bonded to another stick. In reality, this is not what molecule looks like. It's not like this. Dia ada buat tunjuk another animation after it shows this. Dia kata molecules are basically a glumpy ball of stuff. So dia tunjuk satu animation. And this is the sharing of electron. So this is, let's say, for example, this is hydrogen and this is chlorine. So this is a better description of what a molecule is. So this is less accurate. This is more accurate. Okay. So why is this more accurate? Because, for instance, number one, macam saya cakap tadi, electrons are not static. It moves very quickly, very fast in a cloud of electron, in a space, in an empty space. So automatically this description is not accurate at all. So this is why this description is better. It shows that electron moves within this cloud. So what is cloud in here? Basically the space within this circle. So if hydrogen and chlorine form a bond together, they each have their own cloud. So this is the cloud of hydrogen within this circle. And within this Cl circle is the cloud for chlorine. So when electrons, each of their electrons are attracted to each other, they share their cloud. So this electron of hydrogen can venture, boleh masuk dalam cloud chlorine. So dia boleh move dalam cloud chlorine. Electron from chlorine boleh masuk dalam cloud hydrogen. So that is actually what molecule looks like. So this is why this depiction, this animation dalam video tadi tu is a better description of what a molecule looks like. So right now, then I explain why do we find out this is what molecule looks like. So dalam video tadi tu he's about to explain. We explain this structure of molecule because of quantum, very mumbo jumbo, quantum mechanic wave function. So what is this quantum mechanic wave function? This is just a fancy term. Okay, satu ayat-ayat teknikal yang menerangkan how electron exists and behave. Okay, so what actually makes a molecule adalah the transfer ataupun the sharing of electron. So that's how, untuk explain the structure, the shape of molecule, kita perlu explain the behavior of electron. So let's go back to the video. Apa yang cuba dia nak cakapkan about the behavior of electrons.
What old people use. So let's start there. Oh, look, I've got a telephone cord. This is what old people used to use to get their voices into wires so they could be transmitted across the world before cell phones. But today, it's pretty much only useful for demonstrating electron fields. Electrons are both particles and waves, which is not an easy thing to imagine. Very basically, you can think of them as an excitation of the electron field, which exists everywhere. When energy is dumped into the electron field, electrons exist inside a wave function. What's a wave function? It's a mathematical function that describes the probability that an electron is in a certain place at any given moment. So if this telephone cord is an electron field, I dump some energy into it and we create what's called a standing wave. The wave function is the mathematical function that describes it. Electrons function the same way. They exist as excitations in the electron field around the nucleus in a standing wave. The simplest of these wave functions is the s orbital, which can contain 2 electrons and is a spherical pattern of standing waves around the nucleus. This standing wave can have different numbers of nodes, allowing patterns to repeat themselves when there are more electrons around the nucleus. Every orbital can contain, and indeed is at its lowest energy when it contains 2 electrons. Hydrogen has 1 electron in its s orbital. Helium, an ultra-stable, very low-energy noble gas, has 2. It's happy because it has its shell filled. But of course there are other sorts of orbitals as well. After we fill the first and second s orbitals, we move on to filling the p orbital. Or rather, I should say p orbitals, because we're talking about 3-dimensional space here. So there can be one on the x-axis and one on the y-axis.
So apa dah kita dah go through right now. So dalam this video here, this part here, that explains the property of electron. Okay, dia kata tadi electron ni they behave as both a particle and a wave. So what does that mean? That was my question dulu when I was a student. Bila lecturer saya kata electron ni dia bergerak macam what's wave? Macam gelombang dan juga macam zarah. Okay, so what does that mean adalah zarah dia bergerak dalam movement, random movement, Brown movement if you remember. It moves just randomly. Okay, it moves around with no obvious pattern. Okay, that is what it means bila kita kata sesuatu bahan tu it moves like a particle. Secondly, when we say a substance move like wave, macam gelombang lah. So dalam video ni ditunjuk, just imagine you take you take a rock and you throw the rock into water, kamu akan nampak a disperse of a wave. Okay, gelombang tu makin lama dia makin besar. So that is basically if we observe the wave daripada from the surface of kenapa lah saya nak guna tangan saya boleh lukis. Okay, so let's draw. So if we take first kita go back, okay, particle macam saya cakap tadi, it moves randomly. It moves from one point to another point. So that's what it means bila cakap sesuatu bahan tu it moves like a particle. Bila kita kata satu bahan tu bergerak macam wave, what it means is it moves in a pattern like wave, a wave like pattern. So tadi saya bagi example, if you take a small rock, you throw that rock into water, kamu akan dapat from the top, kamu akan dapat nampak this pattern, this thing. Okay, kamu akan nampak gelombang air disperse from the center, from a small center, and makin lama dia akan membesar. So if you observe this wave from the surface of water, kamu boleh nampak dia punya ni lah. If you take this, kita observe from the surface of water, kamu boleh nampak dia akan So this is initially what the water looks like before you throw in the rock. So once you have thrown in the rock, dia akan hasilkan gelombang. So this gelombang is basically just a movement of water energy that is thrown on the surface. It ripples. Okay, so this is what we mean bila sesuatu bahan tu bergerak macam gelombang. It moves in waves. So electron do both. So not many things behave like this. Another thing that moves like this adalah photons, light. So electrons and light, they both behave as particle and also wave. Okay, so why is this important? Kenapa kita kena explain electron move as particle and wave? Because this is important to explain how electrons form molecules. Bila saya kata dalam contoh saya tadi tu, bila satu atom, electron for example, dia ada satu electron. And then we have another atom which is chlorine, which with its own one electron dalam dia punya outer valence. So what happens is dia akan be attracted to each other because this is more electronegative. The electronegativity is higher.
Baba.
Positive. No.
Baba.
Yes. Sorry guys. What's that? Okay, apologies, sorry. So when this happens, kita akan dapat satu ikatan, a sharing of electron between chlorine dan juga, let me draw hydrogen. No, what?
Baba.
No. Well, 1 minute, let me draw.
Baba.
Ada orang.
Baba.
Okay, let's go. Chop. Tomato. That's all. Okay, I'm back. So hydrogen. So we have another atom here, hydrogen, and dia kongsi dia punya cloud. Dia also dia punya electron. So here saya nak explain what does this cloud mean. Okay, apakah itu cloud? Dalam video tadi tu, that's what he was about to explain. Kenapa? Why does this cloud exist and what is it made of basically? Okay, so let's go back to the video.
I dump some energy into it and we create what's called a standing wave. The wave function is the mathematical function that describes it. Electrons function the same way. They exist as excitations in the electron field around the nucleus in a standing wave. The simplest of these wave functions is the s orbital, which can contain 2 electrons and is a sphere.
Okay, so sekarang apa yang dia kata adalah elektron ni dia bergerak as a standing wave. So what does that mean adalah dia akan bergerak bila dia dapat tenaga. Macam manusia, macam kita lah. It is easier for us to move when we have energy. We are stronger when we have more energy. So the same logic applies here for electron. Once it gets energy, dia boleh bergerak dengan lebih jauh from the nucleus. So imagine this cloud is formed by the movement of electron. So certain electrons of certain atom, dia boleh dapat a certain amount of energy saja because of the ability or the amount of electron yang dia ada. Okay, so that's why certain elements are bigger. Elemen yang banyak elektron, dia punya electron cloud dia lebih besar. This, kalau kamu tengok dalam periodic table, hydrogen is the first element in group number 1. Chlorine is the 17th element. Is it 17? Dia dalam group 17. Okay, dia ada 35 elektron. Okay, dia dalam group 17. Hydrogen ada 1 elektron, chlorine ada 35 elektron. So that's why kalau kamu, if you Google the electron orbital for hydrogen, dia hanya ada 1 saja. Dia akan draw like this. Hydrogen with 1 electron. Tapi for chlorine, because of the amount of electron yang dia ada, dia boleh absorb more energy. So dia ada 35 electron. So the first orbital dia ada 2 electron. That's the most first orbital boleh pegang. And then the second orbital dia ada 8. 1, 2, 3, 4, 5, 6, 7 dan 8. And the third orbital also ada 8. 1, 2, 3, 4, 5, 6, 7 dan 8. And fourth orbital also ada 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 lebih 24, 26, 27. So in the fifth orbital, dia boleh hold as much as 10 electron. Tapi elektron chlorine ada 35 sahaja. So right now dah ada 27. So dia ada 8 lagi remaining. 1, 2, 3, 4, 5, 6, 7 dan 8. But maximum the fifth orbital boleh pegang sebanyak 10 elektron. So kat sini saya cuba nak tunjuk pada kamu, the more electron sesuatu atom tu ada, dia boleh absorb more energy. So bila dia ada more energy, the electron cloud gets bigger. So because dia boleh bergerak dengan lebih jauh from the nucleus. The center, the Cl ni, this is the nucleus lah. Let me draw with a different color so that you won't get confused. So the center, chlorine, this is the nucleus. So once this electron ni, this one for example, because it absorbs more energy, dia boleh melepasi, dia boleh lawan daya tarikan nukleus dia. So it can travel farther from the nucleus. That's why the electron cloud for chlorine is that big. Okay, so itu yang cuba dijelaskan dalam video tadi itu. Electron behave as a standing wave because once it's absorbed energy, dia boleh grow farther from the center. Sama macam dalam contoh yang saya bagi tadi, bila if you take a small rock, you throw the rock into water, the wave gets bigger. So the first ripple that is formed bila kamu baling batu tu, that is the most, that ones yang terima paling banyak tenaga. So ombak tu dia boleh go the farthest. Okay, kalau kamu paling batu, once the batu reaches the surface of the water, tu tenaga batu tu yang paling banyak dia akan disebarkan pada air. So the first ripple, the first ombak yang terhasil tu, that is the ones yang mempunyai paling banyak tenaga. So that's why it goes bigger. That's why dia duduk paling luar sekali. So dia yang boleh travel paling jauh. So imagine in that example, batu tu it carries energy, dan dia bagi energy tu pada permukaan air. Imagine the first ripple tu is the ones yang ada paling banyak, ada elektron yang boleh absorb paling banyak tenaga. So elektron akan travel with the space, energy yang terhasil from that rock yang kamu throw. So this is the same logic here. Imagine this is the ripple of the ombak yang bila kamu baling batu dalam air. So this is the center. Kamu baling batu jatuh at the center, at the nucleus. And then the first ripple yang terhasil akan form gelombang. So imagine the gelombang as electron cloud, and electron yang paling banyak tenaga, dia boleh travel as far as the cloud grows. Okay, so itu yang dimaksudkan dengan standing wave. And then kat sini dia explain the different kinds of orbiter. So let's take a look apa yang dia nak explain kat sini.
Around the nucleus in a standing wave. The simplest of these wave functions is the s orbital, which can contain 2 electrons and is a spherical pattern of standing waves around the nucleus. This standing wave can have different numbers of nodes.
No, wait a minute.
Allowing patterns to repeat themselves when there are more electrons around the nucleus. Every orbital can contain, and indeed is at its lowest energy when it contains 2 electrons. Hydrogen has 1 electron in its s orbital. Helium, an ultra-stable, very low-energy noble gas, has 2. It's happy because it has its shell filled. But of course there are other sorts of orbitals as well. After we fill the first and second s orbitals, we move on to filling the p orbital. Or rather, I should say p orbitals, because we're talking about 3-dimensional space here. So there can be one on the x-axis and one on the y-axis and one on the z-axis. Each of those can contain 2 electrons for a total of 8, with 2 in the s orbital and 6 in the 3p orbitals. And yes, those 8 electrons are the reason for the whole octet rule thing. Remember now, the periodic table is a map of the orbitals as they fill. Elements in the s block are filling their s orbitals, elements in the p block are filling their p's, same with the d's and the f's. So s orbitals very simple, spherical, p orbitals a little bit weirder, d and f orbitals so crazy. Some of the f orbitals in particular have just ridiculously cool geometries. Lots of fancy math is involved in writing out these wave functions and understanding them. So with hydrogen, we've just got the 1 s orbital. It's a sphere, marvelously uncomplicated. But in the second shell, we have an s orbital and 3 p orbitals. The p orbitals, if they were all by themselves, look like this. But when you actually stick them around an atom, the s and p orbitals start to interact with each other, doing their best not to overlap and changing each other. The s and the p orbitals can merge into hybrid sp orbitals. Instead of being 2 different kinds of orbitals, they become 4 identical orbitals trying their best not to overlap. This is called orbital hybridization. When the s orbital hybridizes with all 3 p orbitals, it's called sp3 hybridization, and it forms a tetrahedral shape. And this is that tetrahedral shape. It's the easiest way for all the orbitals to form something like a sphere around the atom, but not interact too much. I didn't do anything fancy to make these balloons take this shape. I just tied them together at the base. They naturally form this shape because they can't overlap with each other. And yes, this is exactly what's going on with water. In water, oxygen's 8 electrons are arranged with 2 in each sp3 hybridized orbital. 2 of those electrons are from hydrogen, 6 are from oxygen, including 2 lone pairs. Those lone pairs, even though they're not participating in any bonds, still have their orbitals. And so water is locked into that tetrahedral structure. No matter which orbital you stick the hydrogen atoms to, you're stuck with an asymmetrical molecule. That, along with the difference in electronegativities of oxygen and hydrogen, leads to the polarity of water and the existence of life. But s and p orbitals can hybridize in other ways as well. How, for example, could you imagine sp3 orbitals forming a double bond? You can't have 2 orbitals mashing together in the same space, and sp3 orbitals are pretty much stuck in their tetrahedral structure. Well, if a molecule is going to be at its lowest energy state by forming a double bond, it has a nice simple solution. It only hybridizes 2 p orbitals with the s orbital, forming 3 sp2 hybridized orbitals with an unhybridized p orbital sticking up from the center. Tie balloons together like like that, and you get what we call a trigonal plane. Each sp2 orbital is 120 degrees away from the other, drawing a line straight through their centers, and you get an equilateral triangle. One of the two bonds in the double bond has sp2 orbitals merging together nicely in line with the nuclei. This straightforward sort of bond is
Okay,
called
let's pause here.
Yeah.
Okay, choke also.
Yeah.
Okay. Let's take 5 saat. Nanti saya akan explain buat kita tengok dalam video tadi. Okay, I'm back. Apologies for the gangguan. Anak saya demam, so dia cranky sikit. Okay, so dalam video tadi tu, kita rewind balik sikit. From sambungan daripada kita dah faham tentang wave function, bukan wave function, from standing wave tadi, how electron moves. Dia ada jelaskan, dia ada cakap tentang orbital. So orbital is basically the cloud of electron lah. Tapi specifically limited to the energy sesuatu elektron tu ada. So dalam the first orbital, saya nak buka balik the video tadi tu, rewind balik sikit. The first orbital yang dia jelaskan adalah, let me pasangkan sikit. Ada banyak orbital kat sini. Okay, the first orbital yang dia kata adalah the S orbital.
Hydrogen has one electron and it's as lowest energy when it contains more electrons around the nucleus. Every orbital can contain allowing standing waves S orbital, which can contain 2 electrons and is a spherical pattern.
Okay, so ini yang saya nak kamu absorb from this topic. The types of orbital. So the first orbital kat sini adalah S orbital nama dia. S and it contains 2 electrons. Dia boleh pegang sebanyak, bukan pegang, it's a space where 2 electrons only can fit. Okay, kalau because they are a limited energy. So these 2 electrons move around this spherical pattern. It moves in a spherical pattern. So S orbital moves in a spherical pattern. So untuk, for example, hydrogen, so dia ada satu saja orbital and dia punya orbital is S. So dia punya electron configuration, which I will explain later, is S1, 1s1. So this electron of hydrogen, it moves in a sphere in S orbital. So imagine this is the nucleus of hydrogen. And its electron, let me draw like something bright color. So the electron moves around randomly dengan secara rambang, secara rawak in a sphere pattern. So it goes vertically, it goes around like this, it goes like that, it goes circle around it. So this is S orbital. This is S orbital and 1 electron boleh bergerak. So it's like a globe lah, a sphere. So that 1 electron moves around in that cloud. Itu adalah, the yellow is the electron. Okay, so the black circle in the center, that's the nucleus. And the doodle tu adalah dia punya pergerakan lah. Kalau saya imagine, if we track the movement of the electron, dia akan form like a sphere. Okay, so electron tu tak boleh keluar from that sphere because dia tak ada tenaga yang cukup untuk pergi lebih jauh daripada nukleus. So to travel lebih farther from the nucleus, it needs more energy. So if we blast certain energy ray kepada elektron, kepada atom ni, elektron tu akan serap that energy and it can travel farther, just like humans. If you don't eat enough for the day, then you don't have energy to go out of the house. If you eat a lot or if you eat enough for the day, then you can travel farther from your house. So imagine the house is the nucleus and you are electron. So when you get energy, you have energy to travel farther. The house is your s orbital. So once you have more energy, you can travel away from the s orbital. You can make another orbital, which is the p orbital. So untuk elektron dalam hidrogen ni, dia tak ada p orbital. Dia only have s orbital. But for chlorine, it has a p orbital. So imagine a p orbital, because of its higher energy, dia tak form bentuk sfera. So dia punya shape is a bit wonky. So let's go back to the video. Dia tunjuk tadi p orbital dia boleh hold as much as
Pattern of standing
6
waves
orbitals.
around the nucleus. This standing wave can have different numbers of nodes, allowing patterns to repeat themselves when there are more electrons around the nucleus. Every orbital can contain, and indeed is at its lowest energy when it contains 2 electrons. Hydrogen has 1 electron in its s orbital. Helium, an ultra-stable, very low-energy noble gas, has 2. It's happy because it has its shell filled. But of course, there are other sorts of orbitals as well. After we fill the first and second s orbitals, we move on to filling the p orbital. Or rather, I should say p orbitals, because we're talking about 3-dimensional space here. So there can be one on the x-axis and one on the y-axis and one on the z-axis. Each of those can contain 2 electrons for a total of 8, with 2 in the s orbital and 6 in the 3p orbitals. And yet,
so dekat sini dia kata p orbitals basically ada 3 shell, ada 3 cloud, 3 separate clouds. So what does that mean adalah dia punya shape ni is mana dah? Kenapa mouse saya stuck? So for p orbital dia ada p x, p y and p z. So what does this mean adalah dia cuba nak gambarkan this cloud dalam bentuk 3D. So you imagine ini paksi X, ini paksi Y, dan ini paksi Z. So this cloud ni, macam saya cakap, this orbital, dia bukan, it's not a thing that you can see because it's just macam atmosfera bumi lah. Kamu tak boleh nampak atmosfera bumi, but you know it's there because we can live on the surface of the earth. If we go outside, kiong. Okay, so the same goes for this electron cloud. Kita tak nampak, but from experiments, kita boleh tahu this is the shape of these orbitals. So untuk s orbital, shape dia sfera. It is bound within this cloud. Kalau p orbital, the shape is not sphere because of its energy, the energy yang diterima tu berlainan dan juga lebih banyak. So dia punya shape is a bit different and it's like this. Let me use another color. So untuk PY, the punya shape is a lobe like this. Untuk that was X. And this is Y. Did anybody say something? Saya dengar bunyi, let me check the chat room. Okay, so nothing, sorry. So untuk paksi Y is like that, paksi Z is like that. So this is where this term comes from, PX, Y, and Z. So this is the cloud untuk p orbital. Kalau electron tu receives more energy, dia boleh travel. This is the behavior of electrons. Because of the behavior of the electrons, it forms this cloud. So from experiment, this is what we observe lah. Okay, so this electron untuk chlorine, especially in the second orbital, in the second orbital yang ada 8 elektron ni, 1, 2, 3, 4, 5, 6, 7 dan 8 ni, this is what they reside in. Okay, so this is untuk hydrogen, this is the 1s orbital and there is 1 electron. This is why I write the punya electron configuration like this, electron configuration. Untuk chlorine, dia punya second orbital yang ada 8 elektron ni, all the 8 electrons akan duduk dalam 2s orbital dan juga 2p orbital. So untuk 2s orbital, bentuknya sfera. So untuk s orbital, the sphere is like this. The orbital is like this. Sfera. So ada 2 elektron bergerak dalam this orbital 2s. So 2s, 2. Electron 1, electron 2. So they move around randomly. Untuk p orbital, dia boleh duduk sebanyak 6. So the total number of electron untuk orbital kedua, in this case adalah 8. 2 campur 6 jadilah 8. So electrons here, 2 electrons here, and 2 electrons here. So this shape ni is formed by the movement of electrons. So electron ni tak static, dia akan bergerak. Randomly, this also akan bergerak randomly, but within this cloud. Okay, this one also the same, dia boleh bergerak dengan random. So itulah yang dimaksudkan dengan these orbitals, 1s, 2s, and 2p. Okay, let's go back to the video. I know it's a lot now. Kamu pun tak pernah belajar tentang ni before this, and suddenly today, 1s, 2s, and 2p.
Yes, those 8 electrons are the reason for the whole octet rule thing. Remember now, the periodic table is a map of the orbitals as they fill. Elements in the s block are filling their s orbitals. Elements in the p block are filling their p's. Same with the d's and the f's. So s orbitals, very simple, spherical. P orbitals, a little bit weirder. D and f orbitals, so crazy. Some of the f orbitals in particular have just ridiculously cool geometries. Lots of fancy math is involved in writing out these wave functions and understanding them. So with hydrogen, we've just got the 1s orbital. It's a sphere, marvelously uncomplicated. But in the second shell, we have an s orbital and 3 p orbitals. The p orbitals, if they were all by themselves, look like this. But when you actually stick them around an atom, the s and p orbitals start to interact with each other, doing their best not to overlap and changing each other. The s and the p orbitals can merge into hybrid sp orbitals. Instead of being 2 different kinds of orbitals, they become 4 identical orbitals trying their best not to overlap. This is called orbital hybridization. When the s orbital
Okay, so this is how bonds are formed, hybridization. So this is the part yang saya nak kamu faham about this topic. Firstly, kamu mesti tahu elektron bergerak dalam sesuatu atom. That's why they can be transferred and that's how they can be shared. Secondly, they move within orbitals. They are known as s orbital, p orbitals, d and f orbitals. Okay, but for our module kita cover sampai p saja, s and p saja sampai maybe the third orbital. Okay, the third shell. And thirdly, saya nak kamu faham tentang hybridization, because hybridization is when orbital from one atom overlap with another atom, forming covalent bond. This is how covalent bonds are formed. Bila orbital tu bercantum, hybrid. Okay, so kat sini kita cakap tentang s orbital dan p orbital overlap one another, forming sp3 hybridization. So hybridization tu, bila saya cakap hybridization, it means one orbital will overlap, bercantum dengan orbital yang lagi satu. So dekat sini dalam skrin ni dia cakap tentang hybrid antara s dan juga p orbital.
Not to overlap. This is called orbital hybridization. When the s orbital hybridizes with all 3 p orbitals, it's called sp3 hybridization, and it forms a tetrahedral shape. And this is that tetrahedral shape. It's
for example, bila hydrogen, the s orbital of hydrogen form a bond with 2 p orbitals dalam 2 oksigen, dia menghasilkan bentuk tetrahedral. So this tetrahedral shape is the hybridization of s and p orbital from hydrogen dan juga oxygen.
It's the easiest.
That's why bentuk water adalah band because it forms this tetrahedral geometry.
Way for all the orbitals to form something like a sphere around the atom but not interact too much. I didn't do anything fancy to make these balloons take this shape. I just tied them together at the base. They naturally form this shape because they can't overlap with each other. And yes, this is exactly what's going on with water. In water, oxygen's 8 electrons are arranged with 2 in each sp3 hybridized orbital. 2 of those electrons are from hydrogen, 6 are from oxygen, including 2 lone pairs. Those lone pairs, even though they're not participating in any bonds, still have their orbitals. And so water is locked into that tetrahedral structure. No matter which orbital you stick the hydrogen atoms to, you're stuck with an asymmetrical molecule. That, along with the difference in electronegativities of oxygen and hydrogen, leads to the polarity of water and the existence of life. But s and p orbitals can hybridize in other ways as well. How, for example, could you imagine sp3 orbitals forming a double bond? You can't have 2 orbitals mashing together in the same space, and sp3 orbitals are pretty much stuck in their tetrahedral structure. Well, if a molecule is going to be at its lowest energy state by forming a double bond, it has a nice simple solution. It only hybridizes 2 p orbitals with the s orbital, forming 3 sp2 hybridized orbitals with an unhybridized p orbital sticking up from the center. Tie balloons together like that, and you get what we call a trigonal plane. Each sp2 orbital is 120 degrees away from the other, drawing a line.
So kalau kamu tak faham lagi, last week kita belajar tentang the shape of molecules, okay, molecular geometry. So in today's lesson is basically this is the prequel lah to that lesson, because this is how shapes of molecules are formed. This is how we explain molecules punya shape. Okay, certain molecules exist dalam bentuk tetrahedral because of their punya hybridization. Certain molecules exist dalam trigonal planar because dia punya hybridization. Different types of hybridization causes the shape of that molecule. Okay, so the behavior of electrons sangat penting for you to understand the shapes and the behavior of molecules. First, the very first thing that you need to understand adalah the behavior of electrons.
Line straight through their centers, and you get an equilateral triangle. One of the 2 bonds in the double bond has sp2 orbitals merging together nicely in line with the nuclei. This straightforward sort of bond is called a sigma bond. A second and weirder bond forms, this one from the unhybridized p orbital sticking out above and below the nucleus. These atoms merge to form a pi bond. That's your nice symmetrical double bond that you see in molecules like ethylene. And yes, sp orbitals, where the s only hybridizes with 1 p orbital, are also all over the place. These occur when an atom is either triple bonded to another atom or is double bonded to 2 atoms. The sp orbital, the one that forms the sigma bonds here, is linear. There are just 2 of them, balloons, easy, see, straight line. The trick is to have those 2 unhybridized p orbitals that can engage in 2 pi bonds, either to form a single triple bond or to form 2 double bonds, like in carbon dioxide. Carbon dioxide's orbital structure is actually really cool, so let's take a look at it as an example. The carbon is going to have 2 double bonds, so it has to have 2 unhybridized p orbitals and 1 sp hybridized orbital. The oxygens are going to have 1 double bond, so they need to set up as sp2 hybridized with 1 unhybridized p orbital for the double bonding. As they come together to bond, the sigma bonds will occur between the hybridized orbitals. Very simple. One oxygen will line up to form a pi bond with the vertically oriented p orbital from the carbon, and the other will line up with the horizontally oriented one. There you have it. Bond, 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 bond. But, of course, as will always be the case in your unrelenting search for more knowledge, there is yet more to learn. D and F orbitals can hybridize with sp hybridized orbitals and with each other, forming some gorgeously peculiar geometries. And when 2 d orbitals hybridize with sp3 orbitals, you get d2sp3, an octahedral structure, which those of you who play role-playing games will recognize as an 8-sided die. These orbital configurations determine the shape of molecules, and the shape of molecules determines how they behave, what forms they take, what properties they have. It's pretty dang amazing, really, that wave functions determining the probable locations of electrons keep water bent and thus polar, and thus able to dissolve nutrients and form a stable home for our cells so that we can walk around as weird bags of mostly water, thinking about stuff, making YouTube videos, trying to learn more about the world, or maybe just trying to pass a test. Thanks for watching this episode of Crash Course Chemistry. If you were paying attention today, you learned that molecules.
Okay, so that was the video tentang introduction to orbitals. Okay, so the key point yang saya nak kamu faham, saya akan ulang lagi sekali. The key point saya nak kamu faham is not that you should be able to explain what is wave function, standing wave, and so on. Okay, the learning outcome of today's lesson adalah saya nak kamu faham. Number one, oh, let me use a darker shade. Number one, what's black color? Okay. Outcome for today, apa yang saya nak kamu faham. Number one, saya nak kamu faham, electron behave as both particle and wave. Number two, due to this behavior, electron dalam atom move in a cloud of electron, ataupun nama lainnya selalu kita guna orbital ataupun shell, macam-macam nama ada. Okay, and this shell exists in different levels. Okay, cloud orbitals exist in levels depending on the energy. Kita ada S orbital, P orbital, D and F orbital. But for our module, kita akan focus on S and P orbital. But remember, kita ada banyak level. Kita ada kita boleh go maybe the third period. So 3 lah. So kita akan belajar sampai the 3 level. So 1S, 2S, 2P, apa lagi? 3S, 3P, and maybe 4S. Okay, and 3D, 4S, and 3D. So this is what we call sebagai electron configuration. Electron configuration. Okay, so kita akan belajar sampai this level sajalah. 1S, 2S, 2P, 3S, 3P, 4S, and 4D. So these are the orbital. 3S, PS, ni adalah orbital. This is dia punya level. Level 1, level 2, level 3, 4, and 3 balik. Okay, these are the 3 things yang saya nak kamu faham, because once you understand this, then we can explain the shape of molecules. Okay, and lastly adalah hybridization, because hybridization is how we explain the shape of molecules. Okay, so these are the 4 things that you should take from this lesson, from that video tadi. Okay, so let's take 5 betul-betul punya, because after this kita nak tengok another video that basically elaborate further on orbital, iaitu orbital the basics. So sementara kita break, I'll play the video on the background.
Okay, so this tutorial is about orbitals. We're going to look at what orbitals are, what they represent, how electrons go in orbitals, the order that they go in orbitals, and the shapes of orbitals. So we know that atoms are made out of electrons, protons, and neutrons. Electrons are very important. The arrangement of electrons really dictates how atoms will interact with each other. But we don't really know where electrons are inside an atom. We can define areas where they are with some high probability, but we can never really know exactly where they are. And so we define these areas as orbitals. Orbitals are areas within atoms where there is a high probability of finding electrons. And it is high probability that is the operative idea here. We don't know where they're going to be all of the time, but we know where they're going to be 90% of the time. That's what's meant by when we say the probability. These orbitals are probability clouds. Let's talk, before we go any further, very importantly about the word orbitals. It's an unfortunate word. It comes from the word orbit, which came from Bohr's idea that electrons orbit the nucleus like planets orbit the sun. And we know that electrons do not orbit the nucleus. And so the word orbitals is often something that can create a misconception with students. It makes students think that electrons orbit the nucleus, and they do not. We only can know with a certain amount of probability, 90%, where an electron might be, but not the path that it's taking. And that comes from Heisenberg's uncertainty principle. And as I said, this is important because the arrangement of electrons determines how atoms interact with each other. Schrödinger, building on Heisenberg's uncertainty principle as well as de Broglie's idea that electrons can act as waves. He created a mathematical model that described these orbitals inside an atom, these shapes, these high probability clouds. But we cannot know precisely where the electrons are inside the orbitals. And again, that comes from Heisenberg's uncertainty principle. So the area where the electron can be found, the orbital, as we just said, is defined mathematically. But we can see it as a specific shape in three-dimensional space. So we're going to take a look at that three-dimensional space. We're going to define it with the three axes x, y, and z, the intersection of which will be our nucleus. So our first orbital is going to be the 1s orbital. And what we're going to do now is take a look at the shapes of orbitals and what they're called. They're always designated with a number and a letter. And the letter designates the shape, and the number designates the energy level. So the 1s orbital is the lowest energy orbital, and the electrons in the 1s orbital are the lowest energy electrons. The problem is orbitals can only hold a maximum of 2 electrons. So if we were talking about helium with 2 electrons, that would be fine. Helium would be happy with the 1s orbital. But what if we were talking about lithium? Lithium has 3 electrons. Where would the third electron go? Well, it would go in the next higher energy level orbital, which is the 2s orbital. Notice that we still have an s orbital, and we still have a spherical shape. But the electrons in the 2s orbital are higher energy, and so therefore, on average, they're going to be further from the nucleus, which describes, therefore, a larger shape, a larger area that they're going to occupy. But again, this is just a single orbital. It can also hold 2 electrons. We still have the 1s orbital inside of it, holding 2 electrons. So with the 2 orbitals we have now, we can have a maximum of 4 electrons. That brings us to beryllium. So beryllium is happy with the 1s and the 2s orbital. But what about boron? Boron has 5 electrons. Where is the 5th electron going to go? So as you may have guessed, we're going to go to another orbital, a higher energy orbital. And here, just to review, we have the 1s orbital that has 2 electrons. We have the 2s.
Okay, I'm back. Okay, so 5 minit have passed. Okay, so dalam video ni, basically what it says from the beginning, saya nak pola apa yang dia kata kat sini. So what is orbital? So kat sini dia kata electrons are part of what makes atom an atom. So sangat penting peranan elektron ni. Without electrons, kita tak akan ada atom. And that makes everything doesn't exist lah. Okay, which is the beauty of what everything is. But where exactly are the electrons inside an atom? Dia kata kat sini, the arrangement of electron dictates how atom interact with each other. Okay, pergerakan elektron tu akan mempengaruhi macam mana sesuatu atom berinteraksi antara satu sama lain. But we don't really know where electrons are inside. Kat sini, this is the next ayat tu is what is important. We don't really know. Elektron ni duduk kat mana, kita tak tahu. So that's why it is wrong for us to kata elektron duduk kat sini static. Because it moves. Bila dia bergerak, we don't really know. And it moves really, really fast. Sangat laju. Lagi banyak energi, lagi laju satu elektron. So kita boleh, how do we explain this adalah dengan kita boleh define. Okay, secara kasarnya, kita boleh predict the area yang mana kita mungkin boleh jumpa elektron. Okay, so dia kata kat sini, we can define areas where they are with some high probability you can find the electrons, but we can never be sure where they exactly are. So this is basically the explanation of what an orbital is. So orbital is the area within atoms where there is a high probability of finding electrons. Ada kemungkinan yang tinggi untuk kita jumpa elektron dalam sesuatu kawasan tu. Itu adalah definition of orbital. Okay, kita tak tahu elektron kat mana exactly, but we know the area where it moves. So that is the definition of orbital. Kat sini dia bagi anggaran peratus, 90%. Kita boleh jumpa elektron dalam orbital tersebut. So bila saya kata dalam s orbital, dalam untuk hidrogen ada 2 orbital, ada dalam bentuk sfera. So we don't exactly know where in the sphere is the electron is because it moves, but we know within the sphere ada elektron, 2 elektron dalam tu. So kat sini they go on and on about ni lah the different concept of the structure of an atom. Kita ada banyak model. Kamu boleh Google just different atomic model yang saya tunjuk dalam chapter tu dulu. Ada yang tunjuk elektron mengorbit nukleus, ada yang dalam bentuk Bohr model yang macam saya lukis tadi, yang klorin yang banyak-banyak bulat tu, that is a Bohr model. So those are not accurate description of what an atom looks like. So the best way to describe an atom adalah dalam bentuk quantum model, dalam bentuk orbital. So this is developed in the 1920s, about 100 years ago, baru lagi. If we're talking about the improvement of civilization lah, human civilization. Within the 100 years, baru kita faham this, how electron behaves. So knowing how electrons are arranged, let me rewind. Knowing how electrons are arranged in an atom is important because that governs how atoms interact with one another. Banyak kali saya ulang ni because sangat penting lah. Okay, so Schrödinger is the person that developed this idea. Dia dengan a couple of his friends, you might know, macam Einstein, Max Planck, Niels Bohr, Rutherford. They all get together and they came up with this mathematical function. Yang dalam the previous video kata the wave mathematical function. So they don't exactly buat eksperimen dalam makmal, but they did they explain the movement of electrons through mathematical equations. Okay, so Schrödinger mathematically described the orbitals inside an atom, but we cannot precisely know where electrons are inside these orbitals. So this is described further dalam Heisenberg uncertainty principle. Never mind that. Okay, so kita boleh describe this orbital dalam bentuk 3D shape based on the mathematical function yang di-develop oleh Schrödinger tadi tu. So that's how we get the shape, bentuk sfera, bentuk lobe, bentuk donut. So the shape that we get to see yang saya lukis tadi tu dalam video duk tunjuk-tunjuk tu is based from the mathematical function. Kalau kamu take that mathematical function untuk S orbital, you put it in a software, dia akan keluarkan bentuk sfera. If you take for the mathematical function for p orbital, dia akan keluarkan bentuk lobe. So kat sini dia tunjuk, if you have an s orbital, we have a small sphere. So 1s is the level, s is the first orbital. So untuk s orbital bentuknya adalah sfera. So it can, dia boleh hold a low energy electron saja. So a low energy electron meaning elektron yang paling dekat dengan nukleus lah. So untuk helium for example, dia ada 2 elektron. So the 2 electrons of helium move within this s orbital. But what happens kalau sesuatu atom tu ada 3 elektron macam lithium? So where's the 1 electron go? So it needs, because it has higher energy, dia boleh go farther from the nucleus. So that creates the second s orbital, which is a bigger sphere. Sfera yang lebih besar daripada 1s orbital. Okay, so sfera ni lebih besar because satu elektron lithium tadi tu, it has more energy. So it can travel farther from the nucleus. So kat sini dia explain lah. Okay, therefore 2s electrons are on average more distant from the nucleus, making 2s orbital larger than 1s orbital because it has more energy. Kenapa dia ada more energy? Dia ada ability to absorb more energy because of the number of electrons yang dia ada, atom tu ada. So now let's take a look untuk elektron yang ada 4 elektron macam beryllium ataupun macam boron. Okay, untuk beryllium it's okay lah because 2s orbital masih lagi boleh hold 2 elektron. So 2s orbital boleh fill up sebanyak 2 elektron. So that's okay. But what happens kalau atom tu ada 5 elektron? So 2 of them goes into, what happens ni? Kenapa hilang? What happens here kalau dia ada 5 elektron? The first 2 goes in the 1s orbital. The second 2 goes into the 2s orbital. But the fifth electron goes into the p orbital. Okay, so why? Kenapa? Kenapa ada p orbital is because of the mathematical function yang dibuat oleh Schrödinger tadi tu. So bila dia form this experiment, thought experiment, math equations, dia kata okay, untuk second orbital, untuk explain this behavior, it exists dalam p orbitals. So this is the shape of p orbitals. So macam saya lukis tadi, it exists dalam bentuk 3D because it's a space kan. So this is the 2x, 2p and 2z. X-axis, y-axis and z-axis. So untuk this is z lah yang melintang macam ni. Yang menegak ni adalah y, yang melintang kiri kanan ni adalah x. So this is the shape of p orbitals. So each lobe ni, each axis boleh hold as much as 2 electrons. So so untuk the first one, y. So 2 electrons boleh move around dalam these 2 lobes. 2 boleh go here. So don't forget, this is we don't exactly know where they are. It's just a probability of finding electrons are higher within this orbital. So kalau kita, excuse me, yes, what? Did I pause? So untuk carbon, for example, dia ada 6 elektron. So 2 electron goes into S, 1s, 2 electron goes into S, and the other 2 goes in 2p. Okay, so either of this lah, they boleh move around within this. So this is what an orbital looks like. So I show you this. It's not because that you have to know all this. It is, kalau saya tunjuk ni, because masa when I was a student, there's no videos like this. But I think bila zaman sekarang ni, bila saya tengok, okay, it's better. So this is why, this is the shape of that orbital. This is why, this is how I understand bila one electron has more energy, they will travel farther from the nucleus. And the shape is so and so. Because of the energy it has, it moves differently, randomly. And this movement random forms a certain pattern. Bentuk sfera, pattern lobe. Okay, so dalam this video right now, dia tunjuklah what happens in reality, what the orbitals looks like. Once again. Okay, so first kita ada 1s orbital. Okay, katakanlah kita ada 2 elektron. So this s orbital dah penuh dengan 2 elektron. And then the third electron, the third and the fourth electron akan go into the 2s orbital. So this is the 2s orbital, a bigger sphere outside the 1s orbital tadi. So this sphere can hold as much as 2 electrons. And then if it has more than 4 electrons, the fourth, the fifth and the sixth, 7th, 8th and 9 and 10 boleh duduk dalam the p orbitals. And p orbitals looks like this. Looks like this. Anytime now. Okay, so this is the px orbital. And then we have the py and pz orbital that can fill up according to the axis. So this is x, y that can go menegak, and z that can go, what's the word? Diagonally. So this orbital, macam saya cakap tadi, macam this video also says, this is the place, the area where there are high probability we can find the electrons. Okay, they don't necessarily stick to this shape, this side saja. They move around, but we have higher probability of finding them within this cloud. Sometimes they maybe move around dekat luar cloud ni. We know that just because of the it moves randomly. Electron moves randomly, but it is higher probability untuk kita jumpa dalam orbital ni. Okay, they move around outside this orbital also, but they move around very fast. And because of the behavior of electron, kita boleh predict using the wave function from Schrodinger tadi tu. We know they form this orbital from the movement, from the behavior. So that's why bila saya kata it's higher probability of finding electron dalam this cloud because of the behavior of the electron itself. So from here on, kita boleh kita boleh explain electron configuration. So apa yang ditulis sekarang dekat screen kamu tu, 1s2, 2s2, 2p6, this is kita panggil sebagai electron configuration. So what it means here, dalam the first level, 1, kita ada satu orbital, orbital s. And orbital s boleh house, boleh ada sebanyak 2 electron. So that's what 1s2 means. And then kalau dia ada more than 2 electrons, the 2 electron akan form a bigger s orbital, which is the second level, 2. S is the shape of the orbital, and 2 is the number of electron yang ada dalam tu. So kalau sesuatu atom tu ada more than 4 electrons, the rest, katakanlah kalau dia ada 10 electron, the first 4 akan duduk dalam 1s and 2s orbital. So all the 6 electron selebihnya akan duduk dalam 2p orbital. So neon, for example, dia ada 10 electron. So this is the orbital shape of neon, atom neon, element neon.
Energy level. The next, so these other orbitals nucleus than the others, and it is larger than 1s, 2s, or 2p orbitals and surrounds them. So we can see the other orbitals still exist inside the 3s orbital, and the 3s orbital with.
So kalau dia ada 11 elektron, for example, macam sodium, the 11th electron akan reside dalam 3s orbital. Okay, so if you go over dalam video tu lagi, dia akan tunjuklah the shape of more orbitals sampai d orbital kat sini. It's very weird, and we get this shape is from the mathematical wave function from Schrodinger tadi. Okay, so that is orbitals and hybridization. Macam saya cakap tadi, if you are too overwhelmed by the information, these are the 4 things that you need to understand. The selebihnya tu is like ni lah, pelengkap. Okay, it is nice to know these things, but not for your level. It's not necessary. These are the things that ultimately yang saya nak kamu faham. Electron behave as both particle and wave. They move in in a cloud of electron yang kita panggil sebagai orbital ataupun shell. And this orbital exists in levels. Level 1, 2, 3, 4, 5, 6, and 7. Because kita ada 3 period. And kita ada 4 jenis orbital, S, P, D, and N. So kita boleh susun them accordingly. Contohnya lah 1s, 2s, 2p, 3s, 3p, 4s, and 3d. And so this can be used to explain hybridization, which in turn can explain the shape of molecules. So if you go over dalam your lecture note, mana dia? Orbital, orbital. Dekat bahagian ni. So hybridization of atomic orbital dalam bahagian lecture note ni is basically what we saw. Oops, sorry. Display setting. Okay. So kamu boleh nampak kat sini, this is what it means by hybridization of atomic orbital. So kalau kita ada S dan P orbital hybrid with one another, this is what they look like. Two sp hybrid orbitals. So this is one s orbital bonded with hybrid with two p orbitals. Explain macam video tadi lah. Okay, dia tunjuk. Well, if the hybridization is sp3, that means one s orbital hybrid with 3p orbitals. So this is the separate orbital. Ini sp1, sp2, sp3. So when we combine, kita dapat bentuk tetrahedral, bentuk the shape of water, the shape of methane. Selalunya atom yang ada inilah 4 molecules. 4 atom, sorry, molekul yang ada 4 atom. So this is orbital diagram. Never mind that. Saya nak go through electron configuration. So this is the one yang di explain dalam video tadi tu, but saya nak go over electron configuration dulu. So what is electron configuration? So dalam electron configuration kita boleh explain, kita boleh write down the name of the level, the name of the orbital and the amount of electron. The uses is more lebih ke arah technical lah, tak practical sangat. Meaning kalau kamu kerja as a chemist, kalau kamu kerja as a pharmacist, kamu tak guna langsung this knowledge. But for the understanding of the basics of how this atom works, it's a good knowledge to have. It's a good skill for you to have. Okay, so let's take 5. Kita ada about lagi, dah nak habis dah. So let's take 5 and then saya akan habiskan this chapter. Okay, the filling of sublevels and the periodic table, electron configuration. And a short slide, less than 10 slides. Okay, I'm back. Come on. Saya nak power through the last subtopic ni. Electron configuration. Okay, so if you take a look dalam lecture note, electron configuration basically it tells us which orbitals the electrons for an element are located. Okay, that's the use. Basically, that's the use of electron configuration. Kita nak bagi tahu, kita nak tahu dekat mana the placement of the electron dalam sesuatu elemen tersebut. So, to understand this, there are basically three rules that governs electron configuration. Number one is electrons fill orbitals starting with the lowest end moving upwards. This is known as the Aufbau principle. What is an Aufbau principle? Aufbau is a chemist, and he comes up with this rule. This is basically what is Aufbau principle. So dalam Aufbau principle, it basically dictates that it basically dictates electron akan fill up orbital yang with the lowest energy first, and then they akan move upwards according to the shell. Okay, so for example, for the lowest energy adalah 1s. So the energy in this diagram increases as we go down. So 1s is the lowest energy. So the first two electron, which has the lowest energy, akan duduk dalam 1s orbital. So kalau the third orbital and the fourth orbital comes around, dia akan duduk dalam 2s orbital. And if it has fifth, sixth, and sampai like 10th electron, dia akan reside dalam 2p orbitals. If it has more than 10, the 11th and the 12th electron boleh duduk dalam 3s. And then dia akan move forward 3p, 4s, 3d, 4p, 5s, and so on sampailah 7p is the last one. So kalau in our module, in our level, kita akan stop sampai dekat 3d sahaja. Okay, period ketiga, elemen dalam period ketiga. So that means if you, saya lupa buka periodic table. Kalau kita buka periodic table of elements, the periodic table of elements is nicely arranged. Periodic table of elements. So periodic table of elements is arranged nicely according to groups and ni kan apa nama period. Saya guna ni je lah senang. Okay, so groups is the ones yang ada from left to right. So dia ada 18 group. Group number 1, group number 2, 3, 4 sampailah 18. Kita ada 7 period. This is period number 1 from left to right. Ada helium and hydrogen. The second period is from lithium to neon. I didn't share my screen though. Oh yeah, I did. The third period from sodium to argon. The fourth is potassium to krypton. Sampailah francium to ognesium is the 7th period. These two here, lanthanide and dekat dua ni, I forgot the other ones. Name apa dia? Lanthanide and the other night, dia duduk dekat sini in between on period 6 and 7. So there is 7 period. So bila kita tulis electron configuration, macam saya kata tadi, kita akan belajar sampai the 3D orbital saja. That means kita akan belajar elemen from helium sampailah elemen dalam period ke-3 sahaja. So from helium sampailah argon. Okay, so for period number 1, number 2, and number 3. Because this level here, 1, 2, and 3 ni, and 4 ni, it dictates the period the electrons are in. So untuk level number 1, that means period number 1. Untuk 2, period number 2. 3, period number 3. So untuk period number 1, elemen period number 1 hanya ada hydrogen dan juga helium. Untuk period yang kedua, kita ada lithium, beryllium sampailah neon. Untuk period ketiga, kita ada sodium sampai argon. So the electron configuration yang kita nak belajar dalam this chapter, kita akan belajar from hydrogen sampai argon. So you should be able to write the electronic configuration from hydrogen sampailah argon. Okay, that's what I'm trying to say. So if you follow this, kamu akan dapat 1s1, 1s2, 2s2, 2p6, 3s2. That's how I understood, that's how I write this urutan ni, 1s, 2s, 2p, 3s, 3p. So 1 is the period, 2 is the orbital, okay, is the level. 1 is the level, 2 is the level, 3 and 4 is the level. S is the name of the orbital, the shape of the orbital. S, P, and D. Okay, so electron configuration that is governed by by 3 rules, and the first one is Aufbau principle. And the second one is, every time keluar nak tukar. The second rule is the Pauli exclusion rule. No two electrons can fill one orbital with the same spin. Ini kita guna kalau kita nak tulis orbital diagram. Macam this one. Saya rewind sikit. Orbital diagram. No, not this one. Saya dah terlepas. This is electron diagram. Orbital diagram, sorry. So this dalam box ni ada arrow naik atas, arrow point bawah, arrow point atas, arrow point bawah. So dalam orbital diagram kita describe the spin. Kita bukan saja describe the susunan of the electron dalam sesuatu orbital, but we also describe the spin of electron, the movement of the spin of electron. Okay, so kalau spin ke atas is one way, spin ke bawah is the other way. Those are the two ways that electrons spin. That's not accurate, but for the purpose of this orbital diagram, that's how we describe electron. Okay, and Pauli exclusion principle basically states dalam satu orbital, kita tak boleh ada elektron yang spin the same way. Kalau satu dah spin ke atas, satu lagi mesti spin ke bawah. That's basically what Pauli exclusion principle means. The third rule is, what is the third rule? Hund's rule. For degenerate orbitals, electron fill each orbital singly before any orbital gets a second electron. The third rule also kita guna untuk explain the orbital diagram. Meaning saya nak guna whiteboard. Meaning kalau saya nak describe the movement, the orbital diagram. Kalau saya nak tulis orbital diagram untuk hydrogen, for example. Hydrogen ada satu. No, hydrogen is not good. Helium lah. Okay, helium ada 2 elektron. 1s2. So dia punya orbital diagram looks like this. Dia ada 2 elektron. So satu must spin upwards, satu must spin downwards. Okay, tapi kalau dia contohnya macam lithium. Lithium dia ada 3 elektron. Sorry. 1s2 and 2s1. So dia punya orbital diagram looks like this. Untuk lithium, dia ada 2 orbital, 1s and 2s. So dia ada 3 elektron. So basically what Hund's rule say is, dia perlu fill up the electron yang spin the same way first. So kalau the first electron spin ke atas, dia akan fill up ke situ dulu. And then the third akan turun balik kat the 1s orbital. Okay, dia tak ditulis macam ni. That's the susunan. This is because kalau macam contohnya sesuatu elektron tu ada more, ada 11 macam sodium. 1s2, 2s2, 2p6 and 3s1. So the rule to write dia punya orbital diagram ni, kita mesti this is 1s, 2s, 2px, 2py, 2pz dan juga 3s. So macam mana kita nak fill up this orbital diagram? Kita fill up dengan elektron yang move the same way first, and then kita fill up turun bawah pula. 10, 11. So this is the way. So that's how we know tak ada elektron fill up kat sini dulu. Yang lower diisi terlebih dahulu, barulah selebihnya dipenuhi. So untuk electron configuration, kita tak guna Pauli dan juga Hans rule. Kita fokus on the first rule sahaja, iaitu Aufbau principle. Electrons fill orbital starting with the lowest end and moving upwards. So untuk this slide, it explains how what does this all mean lah. 2 is the energy level, P is the sublevel, is the orbital, and 2 kecil ke atas adalah number of electrons. So untuk tulis electron configuration, let's take an example, iron. Okay, iron has 26 electrons. So first kamu arrange dia punya sublevels, energy sublevels. Kita ada 1s, 2s, 2p, 3s, 4p, 4s and 3d. So kat sini ada student pernah tanya saya kenapa 4s dulu bukan 3d. Kalau kamu tengok dalam orbital diagram pun tadi, kenapa lepas 3p dia jumpa 4s dulu, termasuk 4s dulu. But then patah balik to 3d. So this is an anomaly, sesuatu yang inilah yang janggal. We know this from experiment. Elektron dia akan fill up orbital 4s terlebih dahulu. Barulah dia akan fill up 3d. This is because the size, the space within 3d itu sangat besar. So it has less probability of finding electron than 4s. Okay, so that's why electron akan fill up 4s terlebih dahulu, barulah dia masuk 3d. So that's the one anomaly yang kamu kena watch out for. Untuk tulis electron configuration, kalau ikut susunan Aufbau principle, this is the arrangement. 1s, 2s, 2p, 3s, 3p, 4s, and then balik to 3d. So kalau we take iron, the element iron yang ada 26 electron, this is how we write the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. If you add all the small numbers kat depan ni, dia akan add up to 26, which is the total number of electron untuk iron. So the sum of the superscript equals to the atomic number of iron. I forgot to change the format. Tak nampak langsung. So kat sini saya kata the periodic table can be used as a guide for electron configurations. So the period number is the value of n lah, macam saya cakap tadi, nombor-nombor yang besar dekat depan tu 1, 2 and 3 and 4. So untuk group 1A and 2A, they have the s orbital field. Groups 3A sampai 8A, they have the p orbital field, and groups 3B sampai 2B have the d orbital field. This is what we call the S block, P block, and D block, and F blocks orbital. Dalam video tadi ada mention about this, tapi saya also ada, tapi saya tak buka. Let me buka satu. Periodic table, mana saya simpan? So periodic table, the elements are arranged nicely, but walaupun dia tidak disusun, macam dalam saya nak tunjuk sekarang ni, but it happens to be arranged nicely based on the which orbital it is filled. Okay, this one. Hey, no, this is not the one. Kena Google juga. Orbital blocks. Okay, so this one. So kita boleh guna periodic table of elements sebagai panduan untuk predict the electron configuration. So kat sini saya open image in new tab. So kat sini dia tunjuk kita ada blocks. Arrangement of element dalam periodic table ni is based on blocks. So untuk elemen group 1 dan 2, they are filled up sampai S block. Which S block depends on dia punya period. So elemen macam hydrogen dengan helium, they are filled up sampai they only have S orbital, 1 S orbital. Kalau group yang kedua kat sini, they are filled up sampai 2 S orbital. So they have 1S and 2S. Untuk period ketiga, they are filled up, diisi sepenuhnya sampai block orbital 3S. Dia turun bawah lagi satu, isi sepenuhnya daripada 1S sampai 4S. Turun bawah lagi satu, in the 5th period, they are filled up from 1S orbital sampailah 5S. Bawah lagi satu sampai 6S. And lastly sampai 7S. Untuk P orbital, they are filled up sampai P orbitals lah. But differ based on their period. For the second period, they are filled up sampai 1S sampai 2P. Kalau macam the third period, they are filled up sampai 1S sampai 3P. So we can use this as a guide. Contohnya kalau saya tengok elemen oxygen, atau elemen chlorine for example. Chlorine duduk sini. So chlorine duduk dekat sini, is that right? Fluorine, my bad. So we take fluorine for example. Fluorine duduk dekat sini. So that means they are it is filled up sampai 2P. So kalau saya nak tulis electron configuration of fluorine, saya boleh tulis dulu dia punya energy level 1S, 2S and 2P. So saya stop kat situ. Kalau saya nak fill up dia punya electron number, saya tengok dekat the total number of electrons of fluorine, dia ada 9. So I just agihkan. Agihkan meaning 1s orbital saya tahu dia boleh fill up sebanyak 2 elektron. So 1s2. 2s also boleh fill up sebanyak 2. So kita dah guna 4. 9 tolak 4 jadi 5. So the remaining electron duduk dalam 2p orbital. Itu yang dimaksudkan bila saya kata kita boleh gunakan periodic table sebagai panduan. So let's take another example macam apa yang besar sikit. Macam iron tadi. Iron duduk kat sini. Kat tengah-tengah ni it is known as d orbital. So kat sini it is filled up sampai 3d. So saya tulislah macam dalam contoh tadi. 1s, 2s, 2p, apa lagi? 3s and 3d. So I stop there. And kita ada 26 electrons for iron. This is fluorine. For fluorine kita ada 26 electrons. So fill up 1s2, 2s2, 2p6, 3s2 and the rest are apa ni? 6 darab 2, 12. Sorry. 6 tambah 2 8, 8 2 10, 10 dengan 2 12. So selebihnya duduk sini. No, not right. Oh, for S dulu lah, my bad. Astaga. I forgot my own rule. 3D, 4S, I skip 3D. Hi. So this is fluorine, this is iron. 1s2, 2s2, 2p6, 3s2, 6, S2, selebihnya 8, 10, 16, 18, 20, 6. Oh. Okay, so that's how we write electron configuration. Any questions so far? So the uses of this, nak lukis orbital diagram, nak tulis electron configuration ni is just for us to be able to identify electron ni duduk dekat orbital mana. Atom ni ada berapa banyak orbital, energy level and so on. So it's very technical, it's not very practical for us as a pharmaceutical chemist, but it is a necessary. Ada kat dalam ni, susah payah saya cari dekat dalam Google. Okay, so it's not necessary for apa nama untuk pharmaceutical analyst. Sorry, it's not very practical for pharmaceutical chemists, but it is a necessary and fundamental knowledge that we must have. So as exercise, kamu boleh tulis ni in your own time. Tapi later today or tomorrow saya akan bagi tutorial lah dalam ITAL. Once saya dah post that tutorial, dia akan consist all of these exercises. So kamu boleh buat lagi more questions if you have problems understanding. So that's it, chapter 3. Thank you. Do you have any questions so far? Kalau tak ada, itu saja. Terima kasih. Macam saya cakap tadi, don't forget to ni. Sorry, Chuan Yi ada tanya soalan tadi. Dah jawab belum soalan kamu ni? Have I answered your question? Sir, why 2P2 not 2P6?
Tidak rasa, saya rasa typo kali.
Oh, okay. So, no problem ah? Okay.
Ya, no problem.
Okay. So, kalau tak ada, don't forget. Kalau kamu belum lagi, dalam chat room ada link untuk kamu register your group for your infographic poster. So, please do so by today because saya akan guna that untuk post, untuk assign your topics. So, later today, saya akan bagi tahu, saya dah assign dan kamu boleh tengoklah with your group members macam mana nak buat your ni. And your due date untuk submit your infographic poster tu adalah pada the last day of this semester before exam week start. Nanti saya akan bubuh the actual date dalam that the Google form yang kamu isi team member. Okay. Tak ada question sir tapi susah. Okay. Never mind, nanti bila kamu buat tutorial nanti about this chapter, kamu tengok balik, you assess balik whether susah ataupun tidak. Okay, because the lecture might be too much, but the exercises, the problems might not be as hard. Okay, ataupun it gets easier once you do a lot more practice. So kalau tak ada question, thank you for attending my class. See you next week. And don't forget to register your team member. Thank you all.
Yeah, thank you, sir.
Thank you, sir.
Bye bye.
Thank you, sir.
Thank you.
Thank you.